Hello learners, I am Dr. Manish Kumar Bhardwaj from School of Engineering and Technology of IGNOU. As you remember, we were discussing about the sewage and sewerage systems. In this series, today I am going to discuss with you the source and flow rate of sewage. So, as it is clear from its name basically, from the name of the topic, that we'll be discussing about what are the sources where from the sewage is generated, and second thing is that what is the flow rate of the sewage which is generated basically from the different sources, and for what discharge or flow rate we should design our sewers. So this is the importance of this topic actually. So it is very easy if you think that whatever water we are consuming, that is being converted into the sewage. But the thing is that how to measure? It is not so simple because it has lot many factors which are affecting the amount of sewage generated or reaching to the sewerage system basically. When we talk about the water supply, this is very easy, that water is supplied through a network of pipes from the source to the different houses, and that amount is basically fixed, that some quantity or discharge at a fixed rate is coming to your house. There may be little leakages, so if you neglect them because these are very little, so that is fixed basically, you can measure easily, you can say that this much of water is being supplied to the different households. But when we talk about the sewage, it is a bit difficult to basically assess or measure that amount of sewage generated which is reaching to the sewerage system basically. The simplest thing is that you can say that water being supplied is being consumed or used by the consumers basically. Then it is being converted into the wastewater. So simplest thing is that rate at which the water is being supplied, if you say that 150 liters per capita per day into the number of persons, capita means number of persons. So number of persons into the supply rate of liters per capita per day, this should give me the sewage generated. But this is not so simple thing, because whole of the water which is being supplied is not being converted into the sewage or wastewater because of different uses basically. Means ultimately the whole water being supplied, is not totally reaching the sewerage system as a wastewater, because there are different uses. Like if we are washing car, then it is not reaching to the sewerage system. So many other examples are also there. So because of that, this simple formula that the water supplied into the number of persons that they are using basically that water, it is not applicable basically because of many factors. What are these factors basically? These factors may be that different uses of water. Then second thing is maybe that losses in that system, in our sewerage system. Then there may be some, not only losses, there may be some addition, means infiltration of water from the other systems basically, like rainwater infiltrating into that faulty joints. So there are so many factors. So let us see what are these basically and how they are affecting basically the sewage generated. So what happens that when I talk, when I say that it is simply you can calculate that water supplied into that persons, but our dry weather flow, what is that? Dry weather flow? Dry weather flow is the flow in that summer season in a combined sewerage system, or in a separate system, our municipal or residential sewage, basically sanitary sewage you can say. So that is the dry weather flow. So that dry weather flow varies basically, and this is not simple equation that discharge into that number of persons basically. So as I told you that water may be lost through evaporation, through infiltration, or some other reasons basically. So that what the sewage generated is not equal to that simple formula basically. So what is the amount which is being converted into that wastewater? That is generally 40% of the water supplied. So it is not 100% basically, only that 40% of the water supplied reaches to the sewerage system as a sewage or the wastewater basically. In well-developed areas, this amount may be large or high. Why? Because there that commercial institutions are there, their industries are there, so they are adding to this sewage, and there this reaches up to 90% of the water supplied basically. So that way there is a variation. So when first I told you that in a normal area or which is not well developed, in that it is 40%, but in a well developed area it may reach up to that 90% basically. So this is a lot of variation is there. So how we should design the sewers? Then question arises. So for minimum flow of 100 liters per capita per day, we should design our sewers. So this is a minimum flow basically. But it is desired that all sewers serving a small area be designed on the basis of a saturation population density. Now question arises, what is the saturation population density? When we are planning sewerage system for an area, there may be a situation that the whole area is not populated. Means there that all houses or buildings are not constructed, markets are not developed at the time when we are designing the sewerage system. But we should not cater to this amount basically. Rather, we should design our sewerage system for the population when the whole area is developed, all buildings are constructed, all persons are living in those buildings basically. So that population will be the saturation population basically, saturation population density. So for this means the maximum number which may be there in that area, keeping in view that we have to design our sewerage system. Now, what are the source of sewage? As I told you that water supplied by the authority in any area will be transformed into the wastewater. So the water which is being consumed by the habitants or residents, that is the source of the generation of the sewage or the wastewater basically. Apart from this, few other quantity of water get added to the wastewater in several ways. What are these ways? First of all, addition due to other private water supplies. Till we are talking about that water supplied by the authority, because this is the authentic amount of water which is being supplied to some area or a locality. But it is not the only water which is being consumed by the residents or the people in that area. People are having their private source also. People are having their tube wells, pumps basically from where they are getting water. And this is being converted into that sewage. So this water, additional water from the private water sources basically ultimately reaching to the sewerage system as sewage or the wastewater basically. In addition to this, some industries are also having their own source of water in addition to the municipal supplies. So this water also reaching to the sewerage system as sewage. So this quantity of water discharged can be estimated by the actual field observations. Because here we are not having any formula that we can calculate and find it. So actual observation has to be done basically for assessing this amount of sewage which is being generated due to the use of the private source of water basically. Then second thing is addition due to infiltration. Addition due to infiltration means infiltration is that something is coming from outside from our sewerage system. And what is the way how it may reach to our sewerage system? It may reach through the faulty joints of our sewerage system or the pipe network basically. So infiltration because of groundwater seepage into sewers through defective or faulty joints formed in pipes result in additional quantity of sewage. The height of water table above the sewer invert level is an important criteria influencing the quantity of water infiltrating into our sewers or the pipes, sewage pipes. The infiltration occur after rain if water table is below sewer invert level, because after rain water starts moving down through the soil, and if faulty joints are there, then it will infiltrate to our sewerage system. So this is how the infiltration of water is going on there into the sewerage system. Infiltration also depends on the permeability of soil, because if at any place if the soil is impermeable, then water will not be able to infiltrate into the soil and reach to the faulty joints. Like clays, it is less permeable. But if sandy soil, silty soil is there, it is highly permeable. It will allow the infiltration and the water may reach to the faulty joints, and ultimately it will reach to our sewerage system. The design discharge can be estimated by using the following suggested discharge values as given here in the table, because it is very difficult to evaluate this infiltrating water basically. So some suggested values are there which are given in this table here, and in different units it is given basically. If we talk about that in liter per hectare per day, then maximum value is taken as 50,000 and minimum value is taken as 5,000. If we are talking in that length, in terms of the length of the sewerage system, then liters per kilometer per day, then it is 5,000 maximum value and minimum value is taken as the 500. If we are talking in terms of liters per day per manhole, then it is maximum value is taken as 500 and the minimum value is taken as the 250. So these are the suggested values, because assessment or evaluation of this infiltration water is difficult. So these suggested values are generally taken when we are designing our sewerage system. In addition to groundwater seepage, storm water, drainage water may also infiltrate into the sewers. This amount is difficult to calculate, and generally no additional provision is made for this quantity. Then how we take care of for this water? What we do that when we are designing our pipes, we are designing for the 3/4 full capacity of the maximum discharge, design discharge. So there is a space in the sewers basically. So this additional amount is taken care of by the additional space that is left in the sewers, because we are designing for 3/4 full at maximum design discharge. Means when maximum design discharge is there, then sewer should be only 3/4 full, means 1/4 of the sewer size remain empty. So this empty space will automatically take care of this infiltration of storm and the drainage water basically. So we are not taking into our calculations for this water that way. Then third thing is subtraction due to exfiltration. This is the reverse of this infiltration process. In infiltration process, the water was coming into the sewerage system through the faulty joints, but the reverse is possible. Where there is a dry area, no water is there, no storm water, rainwater or groundwater is there, rather the surrounding is dry. So in that case, from the leaking joints, basically our sewage will go out from our sewerage system. So exfiltration is the leakage of sewage from sewer to the ground surroundings. Exfiltration results in loss of sewage and results in polluting the underground source of water as well as the contamination of our soil there. This can be avoided by providing watertight joints and sealing the cracks in our sewerage system. Then fourth is subtraction due to water losses. Water losses may occur through loose joints in water distribution pipes and in house connections. Because when we are talking that sewage is generated by the use of the supplied water. So if in supply of water, if there are some leaking joints, so whatever water we are supplying on theoretical basis, that from source of supply of water we are sending 150 liter per capita per day. But if our supply pipes are faulty, if the joints are faulty, then there will be leakage. So the whole amount which we are sending from that source is not reaching to our users basically. So in that case, then there will be a water loss. So ultimately, when the less water is reaching to the users, then less amount of sewage will be generated basically. So as this lost water is not reaching to the consumers, this will not appear as sewage. Then subtraction due to water which escapes the sewerage system. So how some water is escaping the sewerage system? Certain quantity of water which is used for purpose of like boiler feed water, because there in boilers it is being converted into steam basically. There is no sewage or the wastewater is being developed. Then water is sprinkled over the roads. Ultimately it is absorbed by the soil there, or if you are sprinkling water in summer season, it is evaporated basically. Likewise, water sprinkled on streets, lawns, gardens. In lawns and gardens, this is being utilized by the plants and that grass basically. Water consumed in industrial product manufacturing. That water is consumed there in the manufacturing of some product, so it is not converting into that sewage basically or the wastewater. Water used in air coolers. It is being evaporated basically. It is not generating any sewage. So these are some of these uses basically in which there is no generation of sewage is there. So it will not generate sewage and it will not reach to our sewage system basically. So because of that, the less amount of sewage is being developed. The next reason is then how the net quantity of sewage is then calculated. The net quantity of sewage production can be estimated by considering the addition and subtraction as discussed here over the accounted quantity of water supplied by the water authority. That whatever water is being supplied, from there, if some infiltration is there, then we have to add that quantity. If some exfiltration or losses are there, or some such use is there that it is not going to generate the sewage, as I just told you, then this amount of water has to be subtracted while calculating our expected amount of the sewage or the wastewater that should have been generated otherwise. So that way we are getting the net quantity of the sewage. Then what are the factors that affect the quantity of dry weather flow? Dry weather flow depends upon the factors such as rate of water supply, infiltration and exfiltration, population growth, type of area served. So rate of supply and infiltration and exfiltration factors I have already discussed. Population growth, how it is affecting basically that as the population will grow, more consumption of water will be there, so more amount of sewage will be generated. Then type of area, if it is a normal residential area, less amount of sewage will be there. If it is a developed area, then some industries, commercial centers will be there, which will add to our generation of the sewage or the wastewater basically. So these are the factors which affect the dry weather flow, and how do they affect, I told you. Again, just for recalling, what is the dry weather flow? Dry weather flow can be defined as the flow that occurs in combined sewer system during summer season or the flow in separate system. Now, how we determine the quantity of the sanitary sewage? If the rate of water supply and the population to be served is known, then simplest thing is that you multiply the rate of water supply to the population. As I told you earlier, that quantity of sewage will be rate of water supply in liters per capita per day. If you multiply by population, then it will give you the sewage liters per day. But I have already told you that this is not such simple thing. The rate of sewage flow changes in every hour of the day, every day of the season, and every season of the year, because of the water consumption pattern basically. The designer or the planner is actually concerned with the maximum and the minimum flow. This variation of course affects the design of the sewerage system, but a designer is mainly concerned with the maximum flow and the minimum flow of sewage in the sewerage system. These two quantities govern the design of our sewerage system basically. Then the sewer should be designed for carrying maximum load and should ensure that no deposition should take place in sewers at minimum flow. Means we have to maintain a self-cleaning velocity. If some deposition is there from this sewage, some solid, because sewage is containing solids as well as dissolved as well as suspended matter, so some solid and the suspended matter will try to settle or deposit in the sewerage system or the pipes if minimum flow is not maintained, if minimum velocity is not maintained. So a self-cleaning velocity should always be maintained, otherwise slowly this deposition will go on and ultimately it will choke our sewerage system. The maximum and minimum flows are mentioned in the percentages of the average flow. What is the meaning of this? That we find an average flow and the maximum flow and the minimum flow are then represented or mentioned in terms of the percentage of the average flow. Residential areas show a maximum sewage flow between 8 am to 10 pm because there at that point of time the maximum water utilization occurs in the residential areas. This value falls down and reaches minimum between the 1 pm to 4 pm because during that water usage is minimum. Then again in the evening this rate of flow again rises because again the lot many activities in which water is being utilized occur in our households. So that way in a day this is that pattern that high generation of sewage flow, then minimum, then again in the evening it is rising basically. So for this there are formulas that how we evaluate or estimate the maximum discharge. There are two formulae basically. One is Babbitt's formula, another one is Harman's formula. Babbitt's formula says that maximum discharge Qmax can be calculated by the formula that Qmax equal to 5 into Q average upon P to the power 0.2. Q average is the average rate flow and P is the population in thousands. So using these two terms, average rate flow and the population in thousands, we can calculate the maximum discharge. And this Babbitt's formula has a restriction that it can be used for a population which lies between 1 and 1000 only. But Harman's formula has no restriction. You can use for any number of people basically. And this formula says that you can calculate the maximum discharge Qmax as 1 plus 14 upon 4 plus P to the power 0.5 into Q average. So that way we can calculate the maximum discharge by utilizing the average discharge. So these two formula are giving relationship between the average discharge and the maximum discharge. The climate and temperature are another principal factors affecting the sewage flow rate, because in winters use of water is less, so sewage generation will be less, whereas in summers water usage is maximum, so here the sewage will be generated maximum. Average flow is assumed to be in March and April and October and November months basically. Maximum rate of flow may be obtained in December, January, while minimum rate of flow may be obtained in December and January. As I told you that in winters basically less amount of water is generally consumed by the people, while maximum flow will be seen in June and July because maximum amount of water is used in summers. And in July again because storm water is also there, rainwater is also there. The peak factors are used to design a flow slightly higher than the average annual flow rate. That is the ratio of peak flow to the average flow. These are basically the peak factors. Also, maximum flow variations are reflected in domestic and lateral sewers as they receive flow directly from the source. The peak factors are used to design a flow slightly higher than the average annual flow rate, which is the ratio of the peak flow to the average flow. So this is the way how we calculate the maximum discharge of sewage in any particular point of time basically. So that way we discuss that what are the sources of sewage basically, and what is the rate of flow of the sewage, and how this rate of flow sewage changes from time to time. What are the factors that affect the rate of flow of the sewage basically. That way if we have this knowledge, then we can easily use different formula for calculating the amount of sewage that will be generated in any season or at any particular point of time, and accordingly with this knowledge of maximum discharge and minimum discharge that will be generated from time to time, we will be able to design our sewerage systems accurately. Otherwise, what will happen if we are not able to calculate the maximum discharge correctly, then there will be this will cause an overflow of the sewage. You have seen many times that whenever there is a storm, there is a rain basically, then generally these our sewerage systems overflow, and that waste water or the sewage is flowing in the streets, basically on the roads, basically. This is because we have not calculated the required capacity of the sewerage system correctly. If we are not correctly calculating the minimum discharge, in that case again there will be a problem, because of this what will happen, that self-cleaning velocity will not be available. If that Q minimum, you have estimated the Q minimum less than that, which will generate the self-cleaning velocity. So there will be deposition of the matter, of solid matter or suspended matter in the sewerage systems or the pipes, and slowly there will be a choking of these pipes. So both conditions are very dangerous. So I hope you must have enjoyed this discussion, and I hope that you will go through the course material that is provided to you, and will get a deeper knowledge from that. Thank you.